All right, so we're going to take a look at here's how we go from an empirical formula to a molecular formula. So for example, maybe the empirical formula that you found was CH, and then maybe the real molecular formula is C6H6, right? So we're going to figure out how we go from the empirical to the molecular formula. And to do this, we're going to use more analytical tools or more analytical instruments. So we have instruments, which are just a fancy way of saying tools or machines that can, we'll put this in parentheses, weigh a molecule. Right, so you put your sample in this instrument, and what it does, it pops out the molar mass for you, right? So it gives you the molar mass. And this is known as mass spectroscopy. There's many different forms depending on what you're looking at. You can Google them, you can see the instrumentation. We do have some at MSJ. Never mind, we don't have a mass spectroscopy here. But anyways, right, we can use techniques to weigh a molecule. So let's figure out how we're going to do this. So let's say you already analyzed a sample and your empirical formula is CH2O, right? That's your empirical formula. And then you take that same sample and you put it in a mass spectroscopy instrument, and then you get a molar mass of your compound is 180.2 grams per mole. And we want to know what's the molecular formula. So the way that you do this is you take your empirical formula mass underneath your molecular formula mass. That's going to give us some number, and that number we're going to multiply by our empirical formula. So let's go ahead and take a look at this. So our empirical formula is CH2O, so we're going to need to calculate its mass. So we have one carbon. Carbon weighs 12.001 grams per mole, so that right there is our carbon. We have two hydrogens, so it's 2 times 1.008 grams per mole. That's our hydrogen. And then we have an oxygen. We only have one of them. If you take a look at the periodic table, it weighs 15.999 grams per mole, right? That's our oxygen. And so our total mass, our CH2O, is 30.026 grams per mole. And then we just plug that in on top, or my bad, on the bottom here, 0.026 grams per mole. And then we just take our molecular formula mass that was found by our instrument, and we put that on top, 180.2 grams per mole. The grams per mole cancel out, and you get about 6, right? And so what this tells us is there are 6 empirical formulas in the molecular formula. And so what we do is we take our CH2O, and there's 6 of them. So we're just going to multiply this by 6. And then you get C6H12O6. And now you know the molecular formula of your unknown compound, right? So you first found out the mass percent, and then after that, use mass spectroscopy to figure out the real formula. And since you have the formula, you can then really reduce the options of what it could be. In this case, this is the exact formula for glucose, which is basically sugar. And so that's most likely what this sample is. As always, the key to this class is practice. There's some worked out examples for you in the work along, and then there's some worksheets with the key provided in the extra resources section as well.